There is a chemical property that you're going to be responsible for knowing regarding thiols, and that is thiols react in the presence of a mild oxidizing agent, so that's something that is easily reduced, to yield disulfides. So two thiols will join. The hydrogen from each sulfur in the thiol is lost, and a bond forms between the sulfurs. So let's look at this example here. We have two thiol molecules where R indicates the rest of the molecule, and the thiol functional groups are highlighted in red. When these two react in the presence of an oxidizing agent, which is symbolized by this capital O in brackets, we form a disulfide. So each sulfur retains the rest of the molecule that was bonded to it. It loses the hydrogen, and the two sulfurs form a single bond to form what's known as a disulfide. So just want to point out, remember in Chem 151, whenever we had a chemical reaction, we cared about every single atom. In organic chemistry, not so much as we can see here, because where those hydrogen goes is not, it just says they're lost. We don't really care where they go. So when we're looking at chemical reactions in organic chemistry, many times we just focus on the functional groups and what happens to them. So you should know that when two thiols react with a mild oxidizing agent, a disulfide is formed. So for example, let's take a look at this thiol right here, and tell me what forms when it is placed in the presence of a mild oxidizing agent. So pause the video and figure out the product. So when a thiol is oxidized, this sulfur-hydrogen bond gets clipped, and that hydrogen goes to another molecule to reduce it. And what happens is the sulfur forms a bond with another thiol that has also lost its hydrogen. So then we form this disulfide bond between these two sulfurs. So if you got this right, give yourself a pat on the back. And just FYI, we use this ease of thiol oxidation to perm or to straighten hair. So one hair is made up of protein, basically, and one of the amino acids, that is prevalent in hair is cysteine. And cysteine has a thiol group in it. And all amino acids have this carboxylic acid group as well as this amino group, and then they have some other part of the molecule that distinguishes them. So the part of the cysteine that distinguishes it is this thiol. So hair has a lot of thiol groups in it, has a lot of cysteine in it, and so some of the chemicals that are used to give permanent waves or straighten hair will oxidize the thiols and allow disulfide bonds to occur, or they'll break the sulfide bonds that are holding hair in a curl. So just a fun fact about how thiols are related to permanently curling hair or permanently straightening hair.